With the massive planned growth in Indian airports, I'd like to talk briefly about one of aviation's necessary evils, ground power. The show with our Indian partner, we're here today, Flywell Aviation. We have a joint venture company, Flywell Powervamp Ltd, and together we manage and run the air show power and air conditioning at various shows around the world. Without power, the aircraft you see today are just dark, hot, sweaty aluminium tubes, and you can't go into them, you can't sell them, you can't show them to the public. The ground power requirements for aircraft have changed significantly over the past 25 years. 25 years ago, the glass cockpits were just entering the aviation industry in the large passenger aircraft. Most of the aircraft then, it was analog gauges, selecting waypoints en route, and generally speaking, as long as the volts and the hertz were about okay, the power ran and the aircraft were powered, and it wasn't a problem. Back then, it was the era of the diesel ground power units, big six-cylinder diesel units, very, very noisy, pumping out fumes, eye-watering pollution. I have to say that from what I've heard and seen, a lot of that still exists at Indian airports today. Ground power is a necessary evil, and I call it a necessary evil because for the aircraft operator, it is just that. Unless they run their APU or run the turbines, there is no power to manage the power on the flight deck, for the cabin lighting, and so on. The ground power is vital for the operations of today's aircraft. No ground power literally means no aircraft power, no flight deck programming, no cabin lighting, etc. There are three players in this area: the ground power manufacturers like us, the aircraft operator, and the aircraft owner. All are influenced by one factor, and that's the airframe manufacturer. It's the airframe manufacturer, through their avionics software requirements and power requirements, that set the parameters for ground power. With modern business aircraft, such as the G650 Gulfstream, or the passenger aircraft of today, the Boeing 787, or indeed the A380, the days of using badly maintained diesel ground power units are finished. These days, the electrical tolerances of modern aircraft are so tight that the slightest deviation in voltage or hertz or the sine wave of the electronics, and the aircraft will reject it. And this is a major problem for operators flying into remote airports. They'll fly in, connect to the local ground power, and then find that the aircraft will reject it. That leaves them with only one option, and that is to actually run their engines, if they don't have an APU, or run the APU burning fuel at high cost, and of course incurring hours on the engine. Over the years, we've seen power quality steadily increase, driven in part by the glass cockpit and in-flight entertainment systems and so on. These days, whether it is the programming of a flight management system on a small business jet or the A380 or 787 that we have here today, the power requirement is exactly the same. The quality has to be exact and precise. While modern electronics have helped to reduce the electrical loads and growth in aircraft size, the recent move towards electric actuators, such as we're seeing on the 787, has in fact increased the loads. So rather than reduce them, aircraft loads are increasing. GPU manufacturers are busy developing GPUs, ground power units that is, that can handle these heavy inrush currents. And if you've seen the 787 power requirements, it's massive. It's like a small city almost. However, for the aircraft operator and airport owner, there are different issues facing those in India. Consider, for example, market competition and government legislation. Those are two key areas that impact on all these airlines and airports. For the airlines with tough competition, their concern is to keep the GPU operating costs as low as possible and minimize the cost of each turnaround. For the airports, however, they are now starting to face some serious environmental pressures. This may be inconvenient, or it may become a major problem, which it undoubtedly will over time. Ground power is a major source at the moment of pollution, which we know the Indian civil aviation authorities are very concerned about. Many airports now have noise curfews and CO2 pollution targets to meet. Let's take London City Airport. That's in the heart of London in the Docklands. It's a fairly short runway. It's got a 5 degrees approach. It's very, very busy. Since it opened more than 25 years ago, flights have steadily expanded, and there are now 10 busy gates. Those gates are each served by a 90 kVA diesel-driven ground power unit, running all day. Under pressure from the Mayor of London, Boris Johnson, the airport is switching to green power. By green, we mean electrically powered ground power units. The annual reduction in CO2 emissions from 10 large diesel engines running almost continuously from 6 a.m. to 10 p.m., 6 days a week, the CO2 emissions are enormous. The fuel saving bill is approximately £200,000 in cutting out the diesel. That's 2 million rupees, I believe. The CO2 pollution that will be eliminated by going to electric power over the year is more than 2,000 tonnes. That's 2,000 tonnes of carbon dioxide emissions. While, of course, there'll still be a need for diesel GPUs for remote locations, the cost of fuel and maintenance using a diesel is massive. At Miami Airport, International Airport recently, according to a study carried out by the airport, by installing electric power as compared to diesel power on Concourse H, the airport saved in 1 year an estimated 131,000 gallons of diesel. The cost of that is phenomenal. The reduction in CO2 pollution enormous and far less expensive than burning diesel. For the smaller regional aircraft, such as the ATR or Q400s, which are in revenue service throughout India, the requirement is for 28-volt DC power. For DC power, while this power can be achieved from an electric power cart plugged into the mains, that tends to tie it into the aircraft terminal. There is an alternative that is fast catching on. This is the heavy-duty battery cart. This is a completely self-contained, maintenance-free unit, and like any battery appliance, it's simply recharged after use. What this does, it allows the smaller aircraft to park away from the gate, and it frees up the space at the gate and at the ramp. But let's look again at the issues of noise abatement, as it translates to the airline and the ground power systems. Night noise curfews. They're a thing that are here to stay, and they're becoming ever more prevalent. This airport restriction, often the result of local pressure groups of people who live at the end of the runways, even though they bought the houses after the airport was there, causes a major problem. Let's just take two examples. Madrid Airport in Spain and Exeter Airport in the UK. Exeter is a small regional airport operating mostly DC aircraft. There's no electrical power at the ramp, and the aircraft come in as a hub for flyby aircraft. As we all know, cabin cleaning and deep cleaning usually take place at night. With no electric power available and it's forbidden to run a diesel GPU, it's a real problem for the airlines. They have